Hi, I'm Joe Hupcey, and I'm here with Hirak Roy of the Questa Formal R&D team. So, Hirak, maybe introduce yourself a little, then we'll talk about your work.
Hi Joe, I have been working in Mentor for last 10 years. The first 5 years I was in a synthesis group, and the last 5 years I have been working in Questa Formal R&D group.
Fantastic. Now tell me, how do we map the formal engines to the customer's compute resources?
So Joe, there are two kinds of formal users. The first kind who are like advanced users, and they have lot of resources to do their verification jobs. And the second are like formal app users. So they want just the performance out of the box. The first kind of users, they want more and more control over their resources, and they want them to use very efficiently. So our orchestration is tweaked for both of them. So our app users can use just like 4 processes or 5 out of the box in a single machines, and our advanced users can tweak our engines so that they can run the engines in the grid for a longer time. And our orchestration ensures that if you have thousands of properties, each property gets a fair amount of time across each engine, so that if one engine is good at one property, the results can come out very faster. And if you have thousands of properties, then it's possible that the easier properties you get result very faster. Then that allows you to release some of the resources you have allocated for the jobs.
So let me develop that point. So what you're saying is a user starts, let's say they have 1,000 properties, and very early on, half or even 700 of them get solved. You're saying you can actually free up that extra compute resource and just have a subset of the grid work on the harder properties?
Exactly that. So we have a visualizer based GUI, and we have a process monitor there. You can real time monitor each process's memory and CPU time usage, and you actually can release your resources when you don't need them. We actually inform the user that okay, these many resources cannot be used anymore efficiently because you have very less number of properties to be solved. And at that moment of time, user can take the action, okay, release resources. Or if you think that, okay, you need to add more resources to the job, we always allow that from the GUI.
Now let me come at this from a different direction. And the word I'm thinking of is linearity, right? So back to the beginning of the project, you have 1,000 properties you want to prove. It strikes me that the fairness of this orchestration algorithm allows kind of a linear output, meaning, the more compute resources you give initially, the faster return you're going to get.
That's exactly. So if you just throw out thousands of processes to the formal, and you have thousands of properties, we can ensure that your results are linearly with the number of resources you have thrown to the formal. And once you are done with most of the properties, then it allows you to use those resources efficiently for another task, to release them and use them for another task. And there is no technical challenge to do that. So our technology is advanced enough to use as many resources you throw at to the formal.
So it's interesting. So in the first part of the analysis, you benefit from this linearity and scalability, right? And in the second part, you benefit from efficiency. You can release the resources kind of ironically, right?
That's perfectly right. I think that's one of the things we are proud of that we have. And I don't think our competitors having such kind of technology that you can use those resources so efficiently.
Interesting. Well, hey, thanks for sharing your insights.
Thanks, Joe.
Cheers.